flavor of what these companies are offering through this medium here. But as you say, the fake booth type of idea wasn't really working, and I think we've all come to that realization. Trying to get the engagement. I mean, engagement is the big thing at trade shows, and that's the bit that we all miss.
Okay. Yeah, that's true. And I'm looking forward to getting that back. Whoever thought I would look forward to sitting on an airplane between screaming children with kids kicking the back of my seat and dirty trays and bad service. I mean, and terrible food. Who thought we would have missed that? But I'm actually starting to miss that now. I'm nostalgic over those days.
So how do you think that's going to return? I mean, I think, we're all going to be vaccinated, we hope, by the middle of the summer. But I mean, do you think we're going to have COVID passports? Do you think that we're going to be all jumping on planes to the same extent after this to go to Productronica and things like that? I mean, how do you think it's going to turn out going forward?
Well, I do think that the number one way to get the world vaccinated is, governments can't mandate, they can't strap you to a table and put a needle in your arm. But I think there's a way that's going to happen in another way, which is airlines and cruise ships and convention center venues and things like that will start requiring, basically a vaccination passport mentioned. So I think that's going to get the world to, we don't need 100% of the people to be vaccinated. We need about 75% of the people to be vaccinated for herd immunity, as I understand it. So I think that'll kind of spur people along. I'm looking forward to it. Hopefully in the next few weeks, it'll be my turn, and I have no problem with it. And I understand other people do. In terms of will it ever go back to normal? I don't think so. I think normal is a historical term now, and it'll be I hate to use the word new normal because that's overused these days, but I think there will be a new normal, and that new normal will be a hybrid approach to everything in life, from vacations to travel, to trade shows, to everything. I think, the genie's out of the bottle in terms of how easy we can communicate. Here I am talking
a hybrid vacation
3,000 miles away. What's that?
How do you do a hybrid vacation?
Well, I think that what I mean by that is I think we'll do more staycations than we've done in the past, because I certainly right now, we have the opportunity to do a couple of things that we canceled, even though they're operating, just because I don't want to have to wear a mask the whole time I'm in that venue. So I'd just rather not go. So I think moving forward, people have kind of learned the value of vacationing near their home. My wife and I just bought a pair of electric bikes, e-bikes. And from what I've read, I mean, if I wanted to buy one right now, we bought ours a few months ago, but if I wanted to buy it now, there's like a 6-month wait on most of those things because the sales have tripled because of the pandemic, because people are staying home and campgrounds are booked up for an entire year. At least in the United States. And
the same thing happened with Peloton, didn't it, at the beginning of this pandemic? The Peloton bikes were going like crazy. I think maybe they're just trading them in for the real thing now.
Right, but I think people are learning that there's things to do in their backyard, and maybe getting on a cruise ship or flying to another continent is not the only way to have a vacation. And I think people are appreciating what's around them a little bit more. Those are little pandemic silver linings, right?
Okay. Yeah, well, I certainly hope we do get back to some kind of normal. We've got a couple of big shows, of course, coming up later in the year with the SMTA event up in Minneapolis, and then closely followed by Productronica. So it's going to be all eyes on trying to see if these events are going to be able to be held as physical events later in the year.
That's right. We also have the High Reliability Cleaning and Coating Conference in October in Dallas, and that right now is scheduled for a live event. Now that's Texas. Right now, everything is live in Texas, right? You can do anything in Texas. Right. You can go to a convention center with no mask, carry a gun, drink alcohol. I mean, there's no holds barred. But we'll see. Not so much if the venue allows us to operate. That seems pretty clear, at least in Texas. We'll see what will happen if people will actually drive there or get on airplanes. Businesses will let them go. That's the big question, whether the businesses will let them go. And
Right.
that's going to be the driving force between a successful event and an unsuccessful event.
Okay. So we've got a couple of people we're going to be visiting here at the Apex virtual event. And the first one is coming up. It's your old friend and colleague, Tom Forsyth, who you know very well, from Kaizen Corporation. And Kaizen are introducing a new cleaning chemistry, the A4382. So we're going to take a trip across to Kaizen now to have a look at it and hear a little bit more about it. And hopefully...
How low can you go?
Low temperature solders enable manufacturers to lower reflow profiles, improve quality, and reduce operating costs. Abstracts are invited from leading researchers, industrialists, chemists, and metallurgists. LTS 2021, June 16th. Click below for more details and to submit your abstract.
Well, there you go. We've got our first glitch of the day. Tom has had some trouble getting in, but we're actively looking for him at the moment, and he'll be joining us, I believe, shortly. So tell us a little bit about, talking about the cleaning industry. How has that changed over the last year or so?
Well, it's been a really interesting journey in the cleaning industry, not just the last year, but for the last 30 some odd years that I've been in it. We went from a conventional process that everyone did to almost a pariah process that no one wanted to do because of the advent of no clean. And now we're coming back into vogue again. And the certain parts of the industry never stop cleaning. The high rel people, the military, medical space, all those people clean because the cost of failure is just way too high otherwise. But the class 1, class 2 manufacturers got a 20-year vacation, and they got to experience the benefits of no clean. No clean is still a wonderful technology, but what we're seeing, particularly in the last year or two, is more and more no clean fluxes are now being removed. They're still being it's still the flux of choice for a number of great reasons, because it's really the only flux today that is actively being engineered and supported and improved upon. I can't think of the last time a new water soluble or an RMA came out, right? They're all no cleans. So they're really good, well-engineered fluxes. But more and more people are now cleaning, and even the commercial folks driven by IoT, by Internet of Things and connected factories and all that, are really driving the cleaning business to historical highs, as at least from our perspective. And I think part of that is
what reasons are they using for that, though? I mean, is that miniaturization or is it just cosmetics?
No, yes, a little bit of both, but well, much of one, a little bit of the other, a little bit of cosmetic. You never want people to see something, even if that something is benign. If something looks dirty, what happens? A customer gets out their microscope, and when they look, they find, and they find anything. And then anything that goes wrong, if their car won't start the next morning, it's because of that spot on the board unrelated to the car, right? Everything is blamed on that. But the big drive is miniaturization. Yeah, the amount of residue that an assembly can tolerate is based upon component density, standoff height, climactic in use environment, things like that. So bottom terminated components have been great for the cleaning industry because they just entrap flux. And voiding, which is associated with bottom terminated components, is great for the cleaning industry because it entraps flux and activators and things like that. So more and more, even commercial assemblers, they basically do to IoT or cleaning, because what do we do with IoT? We attach it to our bodies, we attach it to our clothes, we attach it to our cars, we bring it out into harsh environments. And when you combine a harsh environment with low standoff and a little bit of residue, because keep in mind, when you don't remove the flux, you don't remove anything. Nothing comes off. Everything gets a free ride. The totality of those residues combined with the low standoff heights, combined with fine pitch and very small spaces between conductors, is really creating a fertile field for the growth of cleaning.
Absolutely, yeah. I would imagine that explosion of all this electric vehicle market is going to be a big driver as well. I mean, that's going to increase I mean, they're already cleaning in the automotive industry, but I mean, just the sheer volume of electronics that's coming into the EV market is going to be a big increase in business for the cleaning companies.
Yeah, we sell to automotive manufacturers because it's quite funny. Automotive manufacturers proudly state they don't clean anything because they're automotive, and you know, they coat. If they do anything, they coat, but they don't even clean before coating, and they're quite proud of that fact. But it started off as a kind of a quiet movement. But companies like Tesla and others that have 1,000 volts or more running through their boards, you can't even have a dirty thought in your mind within 20 feet of that board. That board needs to be pristine, and the cost of failure is high. You know, we have the devices in cars now, the electronics in cars now have gone way beyond infotainment and gadgets to safety systems. You know, my car has adaptive cruise control, you know, LiDAR based adaptive cruise control. It has collision avoidance systems front and rear. It has blind spot detection. It has all these technologies that I thought were kind of gadgety at first, but now I trust them. I'm a worse driver today than I was 10 years ago because I'm relying on the technology. And
well, you know, I don't know how much I trust them, Mike. You know, I mean, I've got something that we're going to be talking about tomorrow with Michael Ford and around the issue of security. And there was a very famous IoT device that had a security infringement. It was sending all the information. It was a Roomba vacuum cleaner going around the house and sucking up all the information from every Wi-Fi or Bluetooth connected device and sending it to someplace in China. Now, they found out that the weak spot in the system was actually the LiDAR sensor. They were getting in through the LiDAR sensors, which really made me question, well, wait a minute. These are these things that are critical in all these new electric, you know, autonomous vehicles. I mean, so how safe are they? Right. You know, going back to the question of safety, I'm thinking, you know, and that's a typical issue actually on security with IoT devices. They've got very low security on them. Right.
People don't consider those vulnerable, or they don't consider them essential. And yet one thing connects to another, connects to another, connects to another. And you've got this labyrinth of tunnels that get you to something that's sensitive. It's, you know, the new warfare today is electronic warfare. It's, you know, we are dropping bombs, but basically I think the next frontier of warfare is what we're seeing right now coming out of China and Russia and other, you know, bad actor kind of places in terms of IT. But one of the things with cars, a lot of the technology in cars can be compared to aviation technology. And the difference between a car and a commercial airliner is a commercial airliner has one main system and two redundant systems. So if one computer fails, another computer picks up the task. In a car, we have, you know, one computer for one job. We might have 20 computers, but they're all doing 20 different things. And if any one of them fails, we could be in trouble. In fact, in 2018, BMW recalled several thousand of their i3 electric cars, 2018. And the reason they stated that they had to recall the cars, and the problem with the car is they were shutting down unexpectedly. Now, just close your eyes and imagine that for a second. You're on the freeway, you're about to pass somebody, your car just shuts down, right? You've got 10 seconds to figure out what you're going to do. So it turned out that the problem was a dirty circuit board. Their tier 2 supplier had not sufficiently cleaned the circuit board, and they had another watchdog board that was monitoring the performance of the computers, the various computers. And when it went bad, unlike a commercial airliner, when a computer was sensed to have a problem, instead of kicking in a redundant computer, it shut the car down. So, you know, the automotive industry is facing a challenge, which is to take things that are hoped to be reliable and transition into things that have to be reliable. And that comes with all sorts of things, including cleaning.
Okay. So I'm not sure if we found Tom yet. Yes, and we're ready to bring him in. So let's move over to, there he is, Tom Forsyth, Kaizen Corporation.
Yes, how are you today?
Very good. Very good. You're looking as if you're going to a trade show, Tom.
Yeah, well, that's because I'm at a trade show, right, Trevor? I thought I would get into the full concept here, and after all, I did have to shake a bit of dust off my suit coat, but I thought it worth the journey for you and whatnot.
Yeah, there you go. Great. So, it's nice to see that you're in Dr. Mike's lab, where all the magic happens. And we're here to talk today about the Equinox 4382. It's a new cleaning chemistry for removing organic acid fluxes.
Exactly. And, I'm standing here amidst, amidst an array of cleaning machines, some of which are familiar and others not. If we were to pan around, which we won't, we're going to stay static here. And the whole idea is you're right. This is where the proof is in the pudding. Our lab folks are at the other end of the building doing their design work, but here's where we identify the dilemmas and try to rectify them. Of course, in the case of organic acids, are more popularly known as water solubles. What they've been done, and you and Mike were just talking about it, from the automotive perspective, that, when electronics fail now, it's a stop as opposed to the radio not working. And, well, in water soluble, we've been done in by our densities. We've been done in by the board designs. As you know, I'm shooting this off my new iPhone. I'm sure Mike did before me, but I finally got a new iPhone, and because Mike is always, he's like the day before the rest of the world on stuff like that. We all know this to be true.
I know. Yeah.
So, and notice he's not denying it because we know it's true, right? But
I can't deny it.
And I am like years behind the power curve on this stuff usually. But think of the density of what's going on there. Think of the designs in this iPhone that are different from the first iPhone that was now, 10 or 12 years ago, or the one I was using for the last 5 or 6 years. Well, as everything gets denser, things get tighter, the idea of water all by itself at 72 dynes, reaching into all those crevices, getting in, getting back out, regardless of the mechanical energy that's there to help, at some point, the hole is just a little too small. And so bringing in some cleaning agents that can help that as well, help with that penetration, as well as have a better affinity, better rinsing, all this kind of stuff, really improve the overall nature of the process, and do so very economically and improve that reliability is really a key factor. And so that's where the Equinox A4382, that's what drove that. We've seen that off and on for years. Your leading edge people over the years, they're the people that push the designs. They're the people that have the problems first. You work with them, that solves it, and then all of a sudden, the mere mortals, the regular folks are doing the same challenges, and thereupon now you have some actual market demand for that stuff.
So you answered my first question, which is why do we need it? And you've always answered that quite well. So how effective is it then at removing some of these flux residues? How much more effective is it?
Oh, tremendous. And remember, organic acids by design are water soluble. So if you take a drop of it and you put it in a Petri dish, it's going to go into solution. Okay, so now of course you can overheat things and cause unkind things to happen, but fundamentally you've got a good match there. The dilemma you have is what happens under that 1 mil gap when that water soluble flux, which is designed like all fluxes, they have very low surface tensions. They love to penetrate places. That's their job. Their job is to coat all surfaces and remove those oxides so we get a great metallurgical bond when we're soldering. Well, they also played out on the surfaces in and around all those components and get into very difficult nooks and crannies. And that's the key. The aid that the product really brings is bringing not only its cleaning action, but its penetrating action to get that stuff and remove it, absorb through one means and another to those fluxes, and then be able to be, which is a spy movie, it would be exfiltrate, right? To get back out again, so that the surfaces left behind are cleaned and then dried, as part of the whole normal cleaning process.
Mike, did you have a question? You had something you were going to ask.
Yeah. Well, hi, Tom. It's good to see you. Too bad we're not quite face to face and in each other's booths, but this is as close as we're going to get this year, I guess. Kaizen is a pretty active engineering company when it comes to engineering out new chemicals. And I'm wondering what drives the, last year there was a chemical introduced by Kaizen. This year there's a chemical introduced by Kaizen. What drives that? Is that driven by your customer? Is that driven by a new flux formulation that is just incredibly more difficult to remove? Is that driven by environmental concerns or mandates, or all of the above? What's the primary driver for you guys sitting around going, we have a pretty successful company, we have a lot of great products, let's do another one? What's the driver there?
Well, it depends on your time horizon. In any given couple of months or a couple of quarters, any one of those is typically the driver. As I look back over the many years that we both have been in the industry, it's really all of those things, okay? Because, if we look back to the very beginning, Kaizen was founded because the governments banned ozone depleting products that were destroying the ozone layer over the Antarctic. That was the reason that our company was founded. Okay, so that was a regulatory trigger. When no cleans came along back now 20 plus years ago, well, it turns out that no clean was a bit of a stretch because a lot of people wanted to clean them and continue to clean them, as many people know. Well, in the beginning, they were pretty hard to clean. So that new category of soldering materials drove a long string of innovation to be able to succeed in that environment. But mostly what we do is we're deeply engaged with our customers, and our customers are not only the people inventing tomorrow, literally, right? That's our industry. Our industry invents tomorrow. But our customers in particular tend to be the people that are way at the edge of tomorrow, dawn's early light kind of folks on the technology curve. So they encounter those challenges first. And we believe that's on that particular day, of course, it's a bit of a challenge because maybe we're not answering the mail. But we see that as a great opportunity to get going on those developments early because, there's an old saying that, innovation's not cooking a cake, right? It doesn't come out of a can. You've got stuff to do. It's work to get there. And sometimes that work takes months or even years. We've had products that have taken years to develop to achieve the standards we were shooting for. So that early warning really lets us go. But that customer engagement is key for us. That's probably the most routine trigger where they're trying to do something innovative and a little bit different than the average assembly shop. We look at it and say, well, gee, maybe in 2 or 3 years, everybody will do it. We'll be ready. And we sort it out, which is separate from the random shocks of, regulatory things tend to come every once in a great while as a little bit more of a lightning bolt. Yesterday it wasn't true, but today it's true, and there's a big flash after this stuff. Sometimes innovation on the hardware side, that's your life, and as you well know, you guys also work on it, developing technology, advancing your products, and innovating. And sometimes those innovations make life better for the cleaning materials folks, and sometimes they create some challenges that we're the trade-off a little bit. And so we grin and bear it and kind of sort through that. But those two are more like that regulatory thing. They tend to come in clumps. The average and the steady improvements that we're working on a constant basis across a very broad product line, are that customer driven. Because remember, whether it's batch cleaning, inline cleaning, or rework, or specialty things, stencil cleaning, there's an array of different application-specific products that are all on their own evolutionary cycles.
Yeah. Yeah, there's a lot of new regulations in that coming down the pipe as well, from Europe and different places. And there's always a lot of new flux chemistries coming onto the market that are getting harder to remove. And you've got a fairly unique system there at Kaizen for being able to deal with that when a customer comes into your lab. You've actually got almost like a library of boards on one of the walls in your lab there that has got.
We do. Absolutely. Yeah. And we have several refrigerators full of solder paste.
Right. So you can short circuit the process by, here's one I made earlier, but then we can add some of the bits, to emulate the process you're trying to clean. It's quite a unique system, and very good.
Very much. Well, we've always done that. We've got a big database, an old database that's been around for a long time. It's actually in an upgrade phase at this point, where we track all those different formulations, because you don't get it right the first time. There's a lot of trial and error. There's a lot of, some range of different combinations will probably work. Let's test them all and see which ones show most promise. We were able to compare different raw materials and how they behaved in the past. There's a lot of analytics. Sometimes it's actually chemical lab analytics. Sometimes it's just looking at the data and the result. All right, what's the right path? And we were fortunate in that we started very detailed, dedicated collection of that data a really long time ago. So we've got this great archive that's readily accessible for review and contrast. And that wall of boards still exists here. And when customers come and visit, of course, during the last year, that's been pretty infrequent. They find a toolbox here in our we call it the demo room, even though we don't really sell any of the stuff that's that you can knock on that's sitting here. But it's an array of tools, so you can sort it out. Whether that's you do the testing and wait, let's take a look at this. Let's go shoot it on a high power scope or small enough. Let's see if we can. When we're working in the packaging world, we do a lot of SEM analysis because we've got that scanning electron microscope. We've also collected all those tools over the years, and when they're immediately at hand, that's a great luxury on that day when you really want to know right away, when you could just run over there and get that answer in a few minutes rather than sending it out to the lab and getting some information later. It really helps speed that up. And that's what brings all our product development together. That being able to use those resources to answer things, because when you're experimenting, by definition, you don't really know the outcome.
True.
You have to sort of listen to the data, see those results, process it, understand the variables that you've hopefully isolated well, so you can get that understanding rapidly. And that's what turns into these new products that are. At any one time, we've got many products under development, and they come out when they're done.
Oh, sorry. Excuse me. There's a phone going off. Apologies for that. There you go.
Put $1 in the jar, Trevor. $1 in the jar. We're going to make a fortune.
At least, or a
I know.
during.
I wish the number of times I do things like that. Tom, going back to the Equinox 4382, just what sort of concentration are you having to use with it? And does it concentrate? I'm assuming it differs between batch and inline.
Well, not so much between batch and inline. It tends to run quite low because, again, the nature of this thing is these are the water-soluble fluxes, the organic acid fluxes are things that like to dissolve. Unlike when we're trying to clean a no-clean, where the no-cleans are kind of designed to not dissolve, right, for the most part, to be a bit impervious. So they tend to run at low concentrations. Of course, you have to be able to measure it so you have something. It turns out just sitting a pail or a barrel of our product next to the machine doesn't help. You have to actually get it from that package into the machine, although we've had a few customers try otherwise over the years. So typically down in that 5% or so range, pretty low. It varies by the design and the flux a little bit, and the process conditions. Some people tend to run very hot process conditions that can increase the challenge a little bit. And those are things that our team gets out there. It's not most people actually run this even a little bit below 5, down around 3 sometimes. So it's that whole idea of a little bit goes a long way, which back to the reliability and the benefits for the customer. People are used to using just water, and just water, of course, is only one cost. Having a material in there is a second cost. But at that 3 to 5% range, you're in pretty good shape there, and you're not going to really adversely affect your issue.
Tom, are our friends at AQMD and God forbid SC AQMD happy with this new material?
Well, every year 3 to 5%, they're pretty much always happy. Okay.
Yeah. Right.
They tend to like 25 grams per liter, which is around 3%, right? So most of these products are not 100% solids, unlike some other products. So yeah, they're the kind of people that are very happy with this. And let's face it, as we both know, Mike, if you can make the South Coast folks happy with your product, the world will pretty much be happy with your product. From a DOC
I've said many times that the South Coast Air Quality Management District, which is basically like the AQMD with a calculator with 3 buttons on it, and the buttons are divide by 2 equals. So whatever the
Oh, yeah.
feds come up with, these guys just go, okay, 50? No, we're 25. If the feds go to 25, we'll be 12 and a half. That's pretty much their job.
And they have done that for years. Now, of course, they're trying to keep people safe. And what most people don't know is that in California, what is it? I think there's 25 different air quality management districts.
Yeah, we have a lot.
South Coast being the most well-known. But you're right. I mean, they tend to be picky. But again, these are the sorts of materials that, frankly, are attractive. Water soluble can be attractive in Southern California because of those VOC regs, but designs are running away from it. And that's the challenge, because unlike a no clean or an old-fashioned rosin paste that some of the military people still run, if you leave some residue behind from a water soluble from a organic acid flux, the A is the critical word here, acid. We don't really want to leave residues on our circuit cards. That's almost universally considered an undesirable outcome, right? Being kind here, and so that's where materials being VOC compliant, really line up there and help those folks stay in California, stay local, compliant, but meet the reliability needs that these continuing to increase in density packages and whatnot are now the routine.
Well, I'm sure it's going to do really well for you. I want to thank you for finding your way to our platform today and telling us all about the new chemistry. And we look forward for sure to meeting you in person once we're all vaccinated and COVID free.
Yeah, thank you, Trevor, and I appreciate the opportunity. I have one question for our viewers or listeners. Do we need to invent a new word for what after virtual is going to be? Because I think personally, I'm getting tired of new normal. Maybe you could run a survey, Trevor.
Yeah, exactly.
It can't be old normal, new normal. I don't like new normal. We need some other word. Maybe
hybrid seems to be a favorite word these days, But yeah, it's going to be interesting to see how it all pans out. But I think it's going to take quite a lot of time for everything to get back to the way it was.
I'm with you. I agree completely.
There you go. Anyway, thank you for joining us, Tom. It was great to see you, and we look forward to catching up again soon.
Will do. Thank you. Good to see you guys. Stay safe, and hope to see you again soon. Bye-bye.
Okay, thanks, Tom. I'm here.
Global SMT and Packaging opens the windows of the world to bring you the latest news and technologies from Munich, from Bangalore, from Shanghai, from San Diego.
Okay, so that was interesting. Tom's never short on words.
He is one of the most eloquent speakers I know well. He's just got an artistry with his words, and you have to make cleaning sound eloquent, right? So he does a good job with that.
He's actually one of the smartest people I've met too. He's incredibly smart and well read. I remember a few years ago we ran a bit of a competition at trade shows, where we're doing a quiz show, and when it came to the winners every year, it was always Tom Forsyth and Bob Black. Between the two of them,
right.
They knew everything.
Right, exactly. Yeah, Jeopardy champions. The product that they introduced is actually really good. I've been preaching for a long time that if you have a water-soluble flux, you shouldn't clean it just with water, because all boards after reflow have 2 species of contamination on them. They have polar and non-polar, water-soluble and non-water soluble. And people see the label of the flux and they say, oh, it's water-soluble, so I'm just going to clean with water. But what they're doing is they're leaving all the non-polar species of contamination on the assembly. So yeah, they're getting the flux off, but they're also leaving a lot of other stowaway contamination from board fab, component fab, human assembly processes, things like that. So it's good. I like the idea that they are promoting a chemical that can be used in a water soluble environment, which kind of goes against, common sense or common logic, but it really
Right.
makes a lot of sense because there are many other species of contaminants that need to come off in addition to flux. So it's a good move on their part.
There are, and as I said earlier, I mean, they're always bringing in new fluxes. You talk about Kaizen introducing a new product once a year. When you look at the solder companies, I mean, they're bringing out new fluxes, 3 and 4 times a year. So
Exactly. It is a game of catch up, right? We try in the cleaning industry, both equipment and chemical, we try and be responsive and proactive, right? And sometimes we're a little bit more responsive than we are proactive, just because we think we're seeing 10 years into the future, and it turns out to be 10 months
Right.
with this industry.
Okay, so I want to turn my attention now to some of the new products that we've been seeing. I mean, you've obviously seen some new things in your Reliability Matters program. I mean, what's been your biggest learning experience from that?
We have 63 episodes out right now, and if I were to remove the subject of voiding from that count, we'd probably have 3 new episodes. Voiding is just a huge thing right now. So my guests are talking a lot about low temperature solders to help with one problem, but sometimes they can create another. So it's a balance there.
Yeah.
We've talked a lot about materials. We've talked a lot about failure analysis, things like that. In terms of new products, I think I wouldn't say the technology is new, but the application is new. BTG Labs has a device that measures basically the wetting ability of a surface so that one can do a test and predict the success of conformal coating adhesion. And that's not a new technology, but they kind of put it in a form factor that looks like a pistol, and it's a handheld device. You just point and shoot, and it'll tell you within a few seconds whether you should clean the part further or go ahead and conformal coat it. It gives you a kind of a predictor, which is a pretty cool technology, particularly these days. But most of my guests are talking about best practices, not so much new products, although Mike Bixenman from Kaizen and Magnalytics was on last year, talked about the new Magnalytics SIR tester, which is part of the process that one would use to obtain objective evidence in the IPC J standard Section 8 cleaning quantification. So that was a new product, but most of the conversations are about best practices and my favorite topic, mistakes people make. Process fails. Everyone loves to hear about a failure because it makes them feel better. So we get into that quite a bit too.
You're not wrong there. I mean, engineers love defects. They love to see things failing. I recall back in my early publishing days, we published a magazine or a journal at the time with a very extreme example of tombstoning on it. And the number of calls and emails we got at the time to say, how did they manage to screw it up so badly? I mean, it was just, it really hit a nerve, it was quite funny. But there you go. So getting on to new technologies, we've obviously had been doing a tech talk series throughout the last year during COVID, and some of the new products that we've looked at during that time have been really quite astonishing. And there's one I want to look at now, which came from a company over your way in Southern California, a company called Novacentrics, who have come out with a system for reflowing SAC 305 in milliseconds. Take a look at this clip and I'll show you how it works basically.
For the production of flexible, hybrid electronics, Novacentrics offers a production model photonic soldering tool, as well as the PulseForge Invent, an affordable, minimal footprint, pulse light soldering and photonic curing solution. The base model Invent has a single lamp driver, with additional models available for your high energy, high power needs. The tray is large, with a generous platen and well-positioned magnetic strips for holding samples. The head comes in 2 sizes, 150 or 300 mm. PulseForge tools come standard with a bolometer for measuring output energy of samples, and SimPulse software for simulating and predicting processing results with quantitative visualizations that can accelerate process development. In milliseconds, not minutes, our photonic soldering tools enable soldering of standard lead-free solder pastes, such as SAC 305, onto sensitive components without damaging low-cost, temperature-sensitive substrates. For the production of flexible, hybrid electronics.
Sorry for running essentially the company's promotional piece, but it was the best way of explaining how it works. It's an incredible piece of technology that threatens to upend the reflow process completely. I don't know. Have you seen this before? Have you heard about it?
No, when you and I were prepping for this, I looked into it and I saw the same video and others, and I just kind of, the more I saw, the more questions I had, which I guess is good marketing department, right? But yeah, it looks like it could be game-changing technology, and we haven't had a lot of game-changing technologies in our industry. We produce game-changing technologies. We don't necessarily produce it with game-changing technology. So
Very true.
this definitely could be a disruptive force. I do have questions about it. Based on what I've seen, it generates just a short list of questions, but the concept is fascinating, and it could definitely change the way we're reflowing circuit boards, and it could fix a lot of the issues that we fight daily now.
Right. Yeah. Well, I mean, I think one of the biggest game changers it could do is alter the speed of the line, because typically your reflow oven takes up a lot of real estate, a lot of floor space, but it also dictates the speed of the manufacturing line. So this new technology potentially reflows SAC 305 in milliseconds, and turns the reflow process from being the slowest element on the line to the fastest. So think of the pressure that's going to put on the machines up the line, the pick and place machines, there's everything else. It really is quite a thing. So I asked in my interview with Dr. Rudy Ghosh, I asked him about that, and this is what he said. I think it's coming up, a little bit of a lag. Looking at the regular SMT process, though, I mean, the reflow oven has always been the determinant of the speed of the line. It's the slowest machine, it determines the speed. Using your system, first of all, the footprint is, when you look at the actual form size of it, is much, much smaller. So it takes up a fraction of the space of a reflow oven. Yeah. But I mean, does this process allow the line to go faster?
Absolutely. So we basically take the slowest part of the line and make it the fastest part of the line, right? So that by itself is incredible. Anecdotally speaking, for this specific 0603 LED on a polyimide substrate with with etched copper with an inic finish, I've been able to do that solder reflow and a very, very reliable joint that looks exactly like something that has gone through a conventional oven in a quarter of a second, right? A quarter of a second. And you can process, I'm talking about a single LED, but since this is a wide, it's a broad area lamp, you can do anything within a panel in the 3-inch by 12-inch size within that quarter second. It's possible. Now, the other important thing is going back to the footprint, right? Right now, because the reflow processes are so slow, you actually have only one reflow oven per line. Now, if your reflow oven becomes really, really fast, and you can actually line up, you can use multiple lines coming into a single reflow process, which is, in this case, would be our pulse forge tools. So, it's saving a space. It's in terms of footprint, not only by being small for one line, but it can actually take 10, possibly 10 or even more conventional ovens and replace that with a single tool.
So, I mean, this photonic pulse forge system, it's been around for a couple of years. It's been around for more than a couple of years, because I've been using it on flexible technology, roll-to-roll films and that type of thing, very successfully for quite a while. It's just recently that they've really started to come more into our assembly space with being able to do it on FR4 and the regular laminates that we use in PCB assembly. But one of my questions was, of course, the integrity of the solder joint. How does it affect it? They're putting a huge amount of heat. They're flashing the heat into that solder joint, but they're doing it so quickly that it doesn't have enough time to permeate to any sensitive components that are around it. And it's just it's a very quick and instant heat. Very similar to, I don't know if you remember the nanofoil product that Indium brought out or had a few years ago. Similar type of thing. But I asked them about the integrity of the tensile strength of the solder joint, and this is what Rudy Ghosh had to say.
So that's again a very important question. And as long as conventional substrates like FR4 or rigid substrate like FR4 or ceramic or metal, the tensile strength is pretty much exactly the same that you'd expect from a conventional reflow oven, right? What we have, but again, going back to a lot of the work we have done is also on flexible substrates, right? And in all of those, what we have seen, the failure mode is never the solder joint, but the adhesive that connects the tracks to the flex circuit, right? So either the etched copper or on polyamide or on PET. So that's been very, very encouraging for us. There are a couple of other things that have really been very, very encouraging for us. Is the fact that because we are controlling these pulses, we really have very good control over the peak temperature, how long you keep it at that peak temperature. That really allows us to control the thickness of the intermetallic layer very, very precisely. We can control if you want a 1 micron thick intermetallic layer, we can get that. If you wanted 6 microns, we can get there. Anywhere in between, we can get there. The other important part is the cooling is very, very fast. As soon as you turn the light off, you're taking off all energy sources. The tool does not remain hot. Your cooling rate being very fast basically means your microstructures become very, very small, and that allows a lot of strength for the joint. So these are things that are part of the tool just because of the tool is designed, but because of those specific things that we have been able to do with the tool, we have been able to get very, very good tensile strength of the joints themselves.
So there you go. I'd say fascinating technology, but I'm sure if you've got questions, Mike, we'll be able to get.
Yeah, one of the questions I had was, I watched a lot of their videos, and it was it was a horse race, man. The boards were going through their device at 4 or 5 feet per minute, right? Which is clearly the fastest thing on a production line.
Yeah.
But all the examples that I saw of reflow were solder joints open in the air and LEDs and things like that. What I'm wondering is how this technology works when the solder joint is below the surface of the component, bottom terminated components, BGAs, things like that. I'd be really interested to know how it works on that type of technology as well.
I think it might. Yeah, I think it does have some limitations. I mean, and one of the limitations is obviously it works on color. So the color of your substrate is important. It has to be able to determine which part is solder and which part isn't solder. So it needs that good contrast, if you understand me.
Right.
So there are limitations with it, but I mean, it's still a fascinating technology, whatever way you look at it.
Oh, it's amazing. Yeah, it's amazing to see, and I know it'll just get better. And it probably doesn't need to be faster, because the next slowest thing on the production line is probably the pick and place machine or the printer or something. So, or the cleaning or whatever. So, but it would be nice to get the reflow process working a little faster and more accurately. It has a lot of potential.
Yeah, and I think one of the other beauties about it is that it's very easy to digitize and bring a lot of data off of the process. So for Industry 4.0, for traceability and everything else, it's a much more controllable process in that respect, which is good, because it's difficult to really get a lot of accurate data out of reflow ovens. I mean, it's just the nature of it. I'm really quite excited about that. So lots of other technologies we've seen, but what I want to do now is maybe take a trip over to have a look at one of the panel discussions we've been running. This is another thing we've been doing through COVID. Every week we have a different panel discussion on a different topic. The one we're going to show today is on the topic of best practice hand soldering and desoldering and BGA rework, basically. And here's a clip, basically, of a couple of questions that were answered at this panel discussion about 2 weeks ago, I think it was now. Best preheat source for optimum results. What would you consider to be the best preheat source for, to get the optimum results off the board? Let's go to Jochen on that one.
Yeah, well, to me, the preheat source, I understood it about how should the preheating be done. Like, I would say the preheater must be adapted to the size of the board, because the whole board size has to be preheated from the bottom side, so that the board can relax and can extend even in a balanced way, in a homogeneous way. So the heating must be homogeneous normally for the most of the boards, except some of the boards maybe have some special requirements depending on the board. And so sometimes it is good to have maybe a heating that can be configured in the power, so that maybe one area gets a little bit more heater power and the other area gets a little bit less heater power, depending a lot on the board. The main target should be, of course, to avoid the warpage of the board. So it's a matter of the size. So this also is the key for selecting basically the size of the rework system. If you have only small boards, then maybe a small rework system is enough. But if you have very large boards, then maybe you need XL rework system, because only these systems, they have XL heaters. And mainly the people use infrared radiation from the bottom side, from the most of the systems. So some systems you have with hot air from the bottom side, but if you use infrared radiation, so then the medium wavelength infrared radiation would be maybe a little bit better than short waves, because the medium wavelength has a more balanced absorption than most of the materials.
Okay. Yeah. So Don, would you agree with that? Using infrared medium range would give you a fairly even delta T on the board, and then you use some other source to, around the areas of bigger components?
Yes, yeah, I think he did a great job summing it up. And, there's obviously arguments for what form of heating you use, but I think the most important thing, as he mentioned, is uniformly heating as much of the assembly as possible, ideally the entire assembly, because it's going to minimize the stress, both thermal and mechanical stress, imparted on the board. There are cases we've seen with very, very large boards. We've seen boards that are over 1 meter long, and we've had very good results heating most of the board because it wasn't practical to heat the entire board. So if you have a preheater that's maybe 500 or 600 millimeters and you heat the area surrounding rework, then it's usually very, very effective. We've also worked with some customers that actually have been a little bit more aggressive, where they preheat the board offline and they bring into the process tool a preheated board so that they're saving some throughput. So that's one additional consideration, because in the rework process, preheating can be the majority of the time in the entire process.
Right. So they're preheating it just with a straight infrared heater offline? Is that what they're?
Yes, it could be a preheater offline, and we've manufactured a few. It could be just a basic oven, and they can pull them from the oven and put them on the rework system or bring them to the bench if it's a hand soldering operation.
Okay.
Of course, if they're moving a heated board, they've got to consider the potential human hazards, but you know, when throughput is a key, that's one of the things they can do to speed things up.
Okay. Robert, you got anything to add to what's been said so far?
Yeah, I think that uniform heating is absolutely critical. It's a critical parameter. Big board, small board, flex board, doesn't matter. The fact is the PCB is going to be a thermal drain. So if it's not preheated correctly, then you have to be more aggressive to heat the component on top. In this case, we're talking about BGAs. If the board itself is properly preheated, then you don't have to be so aggressive on the BGA. I talked a moment ago about being able to recycle components to reball them later on, which we'll talk about again later. And so preheating the board correctly is a huge variable in a successful rework cycle. With regard to the source of how to preheat, Finetech Martin uses convection. I'm not personally a big fan of IR, though I know that IR does work. Living in Arizona, in Phoenix specifically, we're very familiar with what IR does to materials. And if there's a car outside that's black and a car outside that's white, you'll see a very different temperature in the summer because IR penetrates darker colors. It's attracted to darker colors. So if there's bottom side components that are BGAs or connectors, they're more susceptible to absorb that energy before the board. And so using convection in our opinion, is a better way to the absorption reflection ratio. And so for the source itself, convection is our preferred method to heat PCBs.
Right, that's really interesting. I didn't realize that infrared was attracted to light in that way. So I guess the color of the substrate would matter as well then. Yeah. Bob, anything to add on that particular topic?
I mean, first of all, the drying the boards. If you're drying the boards, then why not rework the boards after you've dried them? So you've already put the heat into the board. So I would be a great advocate of preheating the boards externally if required. And if they're very large boards, then getting the heat in slowly, as two of the panelists have said, I think is important. And it's the same for, it's the same for just standard desoldering. If we're not talking about the sexy stuff, the through hole. If you have problems desoldering a through hole component, put it in an oven, raise the whole core temperature up. It just makes life so much easier. On the preheat side, I would kind of always look at learning about the machine. So you've got a machine with far, near, middle, convection. So whatever the technology you use, understand the machine, understand the set points, and what is the difference between the set points and the actual on the board. So rather than saying use IR, don't use IR, use convection, don't use convection. If you understand the process more, and obviously you monitor it more closely, and to me personally, at new product introduction, MPI, it is the engineer's responsibility to define how we're going to rework and repair a product. It's his responsibility to check out the components, the equipment's available, etc. You can't legislate for every single component you're going to rework, but that engineering effort should be put in at the start.
Sure.
Not when you have a problem on the shop floor, which
is actually happening. Yeah, it sounds sensible. I'll give you that much, but I'm wondering how often it's done as common practice.
Well, I kick engineers on a regular basis if I possibly can, in the politest, of course. Right.
Okay, moving on. How do you remove underfill on BTCs? We'll give that to Robert first of all.
Yeah, so the first thing to keep in mind is reworking underfill components. Keep in mind that the underfill is there's a purpose for it, right? The whole purpose of underfill is to not ever rework it. They want that component to stay on the board forever. And so it begs the question, why would somebody want to rework a board? And the normal answer is because it's a high value product and they want to be able to recycle it. So that being said, if you go to slot, well, let me say one more thing. Underfill rework is only possible if the material itself is reworkable. So it's quite important that if a company wants to try to rework an underfilled component, they need to get a hold of the underfill supplier and understand what that glass transition temperature is. If the material itself is not reworkable, it'll be nearly impossible to do underfill rework. In the instances that it is possible, if you go to slide number 3 on my that I sent over to you, can you show that, please? Okay, so basically what we've done is we've developed a knife tool that is basically built into one of our soldering nozzles, and the knife tool will allow you to get down into the fillet area between components. I believe the spec for neighboring components is 300 microns, and so what we can basically do is go in and we can shear off the fillet. And so if I go to that one slide, once we've removed the fillet around the component, we have a tool that will then physically go down and grab the component. And again, as we're heating up the component, we can reflow the solder, apply these clamping mechanisms that grab the component, and then lift it off of the PCB.
Right. Okay. Yeah, I mean, that's obviously becoming more and more important with miniaturization coming in, getting into these areas. Okay, Don, do you have anything to add to that about the issues around underfill? I mean, underfill is generally used as a support mechanism for devices, but it's very difficult to rework, or it's painful to rework.
That's true. One of the additional problems that we'll face as we try to do that, and it affects corner glued components as well as underfilled components, is the added force required to separate the component from the board while you're doing the rework. A lot of times you can't rely on the simple vacuum tools we most of us use doing the removal, that you need to apply some sort of force, either a lateral force or a twisting force. So that's one consideration. And of course, that's even more difficult in tight component spacing situations.
So are
go ahead.
Are the adhesives used on corner bonds, are they stronger than you know, is that what makes them so difficult to work with?
No, I don't think the corner bonding is necessarily more difficult than the underfill. In fact, maybe even a little easier. It's just a different approach. Typically, the corner bond would be used on very large BGAs, where the underfill material is wicked in using, you know, basic, you know, I can't even think of the term off the top of my head, but they fill the underfill and it wicks under by capillary action. When you have a very large BGA, say a 60 millimeter BGA, you won't have the capillary action and you have a higher standoff, so the underfill is less practical. And what they'll do then is use a epoxy corner bond or edge bond, sometimes around the whole perimeter of the BGA, for the same effect, providing some mechanical support for the device.
Right.
And in either case, what you have to do is use a tool similar to what Robert mentioned to remove the glue first, and then, as I was saying, apply some additional force during the removal, because it's not just the surface tension of the solder joints anymore. There's still some residual glue bonding strength.
Yeah. Jochen, anything to add to what Robert and Don have said so far on the subject of underfills?
Yes, this is all true. The underfills are really a very difficult thing if used at the components. It's true. It's mainly depends on the material of the underfill which is used. The manufacturer of the underfill knows best how to remove, or if it's removable at all. The IPC 7721 says basically, okay, check the data sheet of the manufacturer. So they don't give so much support in this case. Basically, you need some mechanical support to lift up the component. This is true. Just pulling at the component, no matter if you do it by a suction cap or by a clamping mechanism is already much better than just a suction cap, of course. Is sometimes anyway not enough, but mainly many people use something like a dental tool to just go to the edge and to lift it a little bit, so to crack the connection. Of course, you must be sure that you're over the melting point already, otherwise you have another problem, it's clear. And so in this case, if you can do that, then you can lift it off by a normal suction cap afterwards. But clamping mechanisms are one possibility. There are some systems on the market that use a twisting mechanism, but this is a little bit a problem if you have close adjacent components. So you may move the components then. So there are several possibilities, but one is clear: underfill will always remain a very difficult thing. That's very clear. Beside all that stuff that you have different types and different ways to remove.
Yeah, I mean, Bob, I mean, if a device has got underfill underneath it, I guess the ability to damage the whole the board is greater.
Yeah, chemical things, for example, if you use some chemicals to resolve the underfill, it may also resolve things that shouldn't be resolved on the board. So sometimes this is a really critical thing.
Okay.
Also, especially some underfills, they harden really very much. So even if your component itself that you want to rework is not underfilled and a very close adjacent component has an underfill, then even this can be a problem, because then the solder may squeeze out because it really cracks the underfill and you have these little spots everywhere. And you can't avoid, because you have a heat conduction inside the board of heavy mass boards that go below these underfilled components. You may cool them by adding additional thermal mass and so on. There are several possibilities how to support dealing around with these underfills.
And welcome back. So honestly, there's a lot of really good process tips you get in some of these panel discussions. That was just one of them. And if anybody wants to watch the full panel discussion on rework, of course, it's available on the Global SMT website, but you'll have to register to watch it, but it's well worth watching. That's another area, Mike, that is also changing. The whole soldering area, with robotic soldering coming in, laser soldering, all these types of things. It's going through a lot of change as well.
Yeah, I've seen a lot of changes in rework systems over the years, from hot air gas rework systems to IR to soldering irons and dental instruments. You know, there's everything in between. It is interesting that the amount of technology that's being poured into rework versus the amount of technology that's being poured into making sure we don't need rework. You know, there's a balance between doing it right or doing it over, right? And as the old saying goes, sometimes we don't have time to do it right, but we'll find the time to do it over. So if you don't do it right, you're going to benefit from all these great new technologies and rework.
Yeah, it's an interesting area. I mean, they're trying to automate it by, using robotic soldering, where they're trying to emulate the action of a human being. You know, one holding the solder wire, and the other one holding the tip. But it's it makes it quite expensive to manufacture. So the problem at the moment really is the cost. The cost of making these robotic soldering systems is still a little bit in the high side, but I'm sure that's going to change as time goes forward and new systems come on.
But these robotic soldering systems don't make mistakes like humans do, like pouring way too much flux on a component and the dreaded squeeze bottle thing. They don't make those mistakes. It's people that make those mistakes.
It's very true. Once you set it up and it becomes repeatable, they just don't make mistakes. And I always remember a plant manager telling me one day, he says, even my best engineer in this plant has got 500 DPM in him. He's just my best engineer. He said, so, right. There's definitely a case for automation at times. So anyway, we're going to take a little trip now to Atlanta and visit one of the APEX exhibitors, Ko Young. who've got a brand new demonstration facility set up there, and we're going to join Joel Scutchfield. Welcome, Joel. Nice to see you.
Hello, how are you today?
We're great. It's nice to see you in your brand new facility. I mean, it's, what is it, about a year old now, the new place that you opened in Atlanta?
Almost 2 years. Almost 2 years.
2 years.
2 years in early April. Yes, yes.
Right.
Time flies, right? Of course, last year doesn't count, right?
I think we lost a year, all of us.
But no, welcome to sunny and spring-like Duluth, Georgia. It's another beautiful day, and we're very happy to be here. We are suburban Atlanta, as you mentioned, Trevor, about 40 miles from the airport. This is our new branch headquarters for the Americas, and today we're standing in our state-of-the-art demo center and hoping to show you around a bit.
Okay, well, let's have a walk around and have a look at some of the highlights of what's new in the Ko-Young range.
Sure, absolutely. Let's start with the Zenith 2, which is right beside me here, just so happens to be, right? The Zenith 2 is our top-of-the-line AOI system. It's been out for a few years now, but we continue to evolve the technology, specifically from the side camera perspective. If we go back to the original Zenith tool, you may recall we were using 8 projection analog moire interferometry. With the introduction of the Zenith 2, we're adding in the digital moire, which allows us to modulate the frequency and provide measurement results up to 25 millimeters in height. So where high height comes into play, this is a system where we're going to want to have a conversation. The other added element with the Zenith 2 was the addition of the side camera solution, the 4 side cameras. Now, we don't promote the side cameras extensively because, truth be told, we really don't need to. Our core technology is very capable of tight densities and spacings. Where it really comes into play, as you're well aware, is complete hidden joint, right? So if we're experiencing situations with shields, issues where the component is just completely shielded from the top-down camera, obviously we need the side camera. So that's one system that I wanted to update you on as we go through the day. And I thought maybe what I'll do is just give you. Go ahead, Trevor.
Is that a combination of 2D and 3D in the Zenith 2?
It is, right. So all of our AOI technology does use a combination, but as I've said in the past, we like to consider ourselves more of the 80% 3D, 20% 2D, measurement-based, of course, a true 3D, versus some of the other technologies out there, which are more of the 2.5D variety, being more of the 80% 2D, 20% 3D, if you will.
Okay. Fine. So let's move on to your next machine and have a look around.
Okay, absolutely. We're going to talk very quickly about the Meister series, which is our introduction for the basically semiconductor packaging industry. So we're looking at things like fan-out wafer packaging, flip chip BGA, shiny device, and basically people like OSATs, device manufacturers, even foundries to some degree. But in this particular case, we're looking at components down to the 008, 004 level at 50 micron 2 mil spacing. So very high accuracy, very high measurement resolution, down to 5 micron. And again, offering a solution now both for SPI and AOI for that particular market sector. And again, looking at things like micro cracks, foreign material, all the same types of inspections that we do in a standard AOI environment, but now in that semiconductor packaging world.
Right. I mean, a lot of the semiconductor people are working down to, as you said, the 5 micron, but they're trying to push below that to the sub 5 micron level. Are you getting much, many requests for that?
Well, we are certainly getting requests, and I think it's safe to say the roadmap certainly has that in its mix. So I think soon you will see technology from us that does penetrate below that 5 micron level. Again, voice of the customer. That's what the market wants. That's what the market has to have.
Right. One of the other things we're seeing in the industry, Joel, is a trend towards vertical integration. We've seen a few companies recently where there'll be an EMS company, but they're starting to put clean rooms in there so that they can literally have the packaging capability inside the factory as well. Are you seeing much of that?
Well, it's hit and miss, right? So in our particular world in the Americas, Trevor, as you may well know, semiconductor is still a very small piece of the puzzle, right? But when you get to Asia and other parts of the world, obviously it's a much bigger piece of their particular business. So in those particular instances, I think there is activity along that line. Here in the Americas, we've seen some of that, but again, this is still one of those things where it's almost still nichey. I think we see the 5G drive helping to drive some of that as we go forward. As we know, the semiconductor industry is on fire right now, having a record year. And of course, a lot of that being driven by that 5G need and even beyond. So I think you can expect to see more of that as we go forward. But again, it's always gonna be where it makes most sense, right? It won't be broad scale.
Okay. Fine. So I think the next one you were going to move on to was the Neptune, which is your conformal coating system.
Yes, actually, it's a dispense technology inspection. Conformal coating is certainly a big part of that. I'll step over to this side. The Neptune series is basically a combination, again, of 2D and 3D. The 3D element utilizes a technology called LIFT, which is laser interferometry for fluid tomography. That sounds like a mouthful. It's basically low coherence interferometry, or near IR. And basically what we're doing is we're utilizing a laser through a mirrored spectrum, if you will, creating the incidence of penetration through the fluid to the board surface. From that, we can gather multiple layers of fluidic structure, if you will, and use that data to build our 3D model, much like we do with our standard AOI tools, to take our measurement readings from. So it's very unique. And again, the advantage with this particular tool is we can do those measurements at a much faster rate than the systems that are on the market today. So for example, a 4x4 millimeter field of view can be inspected, processed, and results provided in 10 to 12 seconds. So that gives the customer the opportunity to take more of those height measurements in addition to the 2D coverage and bubble check and de-wetting and all the other things that they're doing without slowing down the production line.
What about the thickness measurement? Because in conformal coating, the thickness of the coating is quite critical. Does that laser is it capable of bouncing off and measuring the thickness of the coating?
It is. In fact, the technology approach that I just described is basically how we're doing that, using that LIFT technology to gather that data to build that model. And basically, we can go from 5 micron to 3.5 millimeters, depending on the actual flavor, if you will, of system that we provide. There's a couple of different options with regards to that. So, but yes, that's what we're seeing from, again, the voice of the customer perspective, where there was a need for being able to do those height measurements very quickly without slowing down the production line, and I think that's what we've come up with here. In addition to that, Trevor, we were able to also, as we go forward, inspect for underfill, height and width, and even LED height and diameter. So there's multiple capabilities built into this particular technology. We're still in a little bit of a pre-release phase right now. This is literally, we've had our demo system here in Atlanta for just a couple of months now, and we're just getting started. You'll hear more from us as the months go by with regards to the official release.
How do you measure the underfill? Are you just measuring the fillet around the side of the device?
Well, correct. Yeah, basically same technology, right? So again, what we can see, what we can measure, if we're unobstructed, we can get through with the laser to the board surface. And again, there'll be more on that as we go forward. A little bit of secret sauce in there as well, right? So we'll be happy to share that at the appropriate time. Absolutely.
Okay. Right. So anyway, Joel, the systems that you've got there, the Ko-Young systems, they're all really held together with your K-Smart technology. How has that progressed over the recent months and years?
Sure. Let's move one station over, and I'll give you a quick overview on that as well. So, Trevor, as you're well aware, the K-Smart tools, which again is basically our brain, if you will, for the entire process in terms of data analysis, connectivity from machine to machine. These tools were introduced years ago, and with very good success. And they were individual elements at that time: SPC, remote monitoring, real-time monitoring, Link for correlating data. What we're doing now in 2021 with the release of the 2.0 version of K-Smart, Ko-Young Smart Factory, is tying all that together into basically a line solution, if you will, and even a factory solution where multiple machines across multiple lines can be fed to a central database hub for analysis and basically fast process resolution, if you will. So you can see a little bit on the screen behind me here where we're adding the element to these individual pieces that have existed in the original release, the addition of the ability to monitor, track, and utilize OEE, basically overall equipment efficiency or effectiveness, as another piece of the puzzle that's telling us what's really going on in the factory. Along with that, now we're incorporating things like reports, customized reports, notifications for out-of-control situations, much more sophisticated in terms of tying everything together and giving you that single source line control, if you will, entity tool that customers are looking for.
Right. Okay.
Yeah.
Mike, have you got any questions on this, or are you?
Well, I have to say, I've got demo room envy here. This has nothing to do with your systems, but I've sat through torturously many online demos, and you guys got it down. It's slick, it's smooth, it's good. Not to mention your equipment, but the presentation quality is very good. I don't think anyone's missing out too much on not being there in person. So good job on that.
We've got really good technical people, Mike, and they're making me look not terrible. How about that? That's about
true.
The best you can do with me. So
yeah, or as my daughter would say, this doesn't suck. You're doing good.
There you go. There you go. Absolutely.
We're
very proud of it.
Yeah.
So
you should be.
I'm sorry.
What are some of the challenges of AOI? What are AOI in your opinion? What things can they not do today that you think in the next year or two they'll be able to do without giving away any secret sauce? Where are we headed with AOI?
Well, I think the software has a lot to do with where we're going to go here, right? Enhanced algorithms for better, faster, all of the above, right? From a information gathering perspective, from a data analysis perspective, we are expanding, as I'm sure our competitors are, at a very fast rate, to include a lot more in the way of through-hole inspection, for instance, right? So there's a lot of things that can still be done just from a capability standpoint that we're working on, and that again, we're using the voice of the customer to help us drive that, right? What's missing? What would you really like to have that you're not seeing today? Denoising software from an image reconstruction perspective. How do we make it better? How do we continue to make what's already really robust even more robust and more reliable? And then utilizing that information to feed our artificial intelligence proprietary, I should say, artificial intelligence engine to better utilize all of that information and make these systems more intuitive, easier to use, easier to analyze the data, basically more productive and more aligned with basically reducing costs in the manufacturing operation, right? Yields up, costs down, right? Repurpose these people that are utilized today for monitoring any group of machines for something much more productive, and utilizing the artificial intelligence and the automation and the connectivity, the CFX piece, all of that to accomplish that.
Yeah, good point. Can I ask you, Joel? I mean, the K-Smart obviously connects with most of the vendors of equipment out there at the moment. What about if you go into a factory where it's got legacy equipment, and it might even have legacy inspection equipment? Is this only going to work with Ko-Young equipment?
So the K-Smart tools, Trevor, are basically just that at this point in time, right? We are well, let me rephrase that. As I shift gears here a little bit and give you a little bit different view of some of the other things behind me. You see the MPM printer, the deck printer. From a KPO perspective, and that's another new tool for 2021, the Ko-Young Print Process Optimizer, second generation. You know, we're working with companies like this. Obviously, we have them in our demo room. That tells you how the partnership has matured to develop this closed loop feedback entity with their technology. So there's a piece of this, and the mounter element that is currently in development kind of follows the same logic, right? We're working with the usual suspects, if you will, on the mounter side for creating closed loop feedback to their tools for things like feeder, spindle, nozzle anomalies, right? At the same time, some of the tools that I showed you previously are a little bit more Ko-Young centric, right? The link ties together our SPI, our pre-reflow, our post-reflow, AOI, and so forth. And a lot of the data analysis that I talked about previously, the OEE calculations, are very Ko-Young centric. But we are, as you may know, I think if what I've been told is correct, the only inspection company at this point to be fully compliant with the IPC CFX requirements for being able to fulfill all of the events, if you will, from a SPI and AOI tool required at this time. So, you know, we're definitely involved at multiple levels, right? When it comes to Smart Factory Initiative, and that's Dr. Ko's objective. You know, he wants us to always remain the leader in that arena.
Right. So one of the key
and it's helping us do that is making sure that we're doing that, right? By helping us fund, if you will, just from a human resource perspective, the time and energy to go do that and spend with those partners to make that happen.
Yeah, well, it certainly has always been out there at the forefront of technology, Dr. Ko. I've known him for many years, even before his days at Ko-Young. So
how about that?
Yeah, absolutely. But a very clever man, believe me. One of the areas that is key at the moment, and that Ko-Young is very involved in, is of course monitoring the print process. But some of the things that we've been monitoring so far are fairly basic. You know, we're looking at we're measuring the SPI, the volume of the deposits, etc. But the printer itself, there's things like squeegee pressure, etc., etc. How are you dealing with that?
So, well, you put that on a tee for me, Trevor. The next piece I wanted to talk about was that next generation Ko-Young Print Process Optimizer tool, the KPO, as we call it, KPO 2.0. And we've had discussions in the past about the three-prong piece to this. We have, starting out at the front end, something we call PAM, which is the process analyzer. That is a tool that will allow you in an automated fashion to undergo an extensive design of experiments for recommendations for speed, pressure, and release pre-production, right? And then the second element of that is what we call PDM, the diagnostics monitor, and that's basically tracking the results and monitoring at a much higher level than the standard closed loop for X shift, Y shift, theta, etc., giving trends information, providing feedback to the user, to the operator, for adjustments that could potentially need to be made based on things that are being seen. Again, hotspots, trending. The final piece to that is what is going to be released very soon with the 2.0 tool, and that's what we call POM, right? Basically the parameter optimizer. So now with the release of that tool, we will have the full capability of not only monitoring the process, but using the machine learning and artificial intelligence to adjust the process through that POM piece for speed, pressure, release anomalies. So now we have the full closed loop control, almost a lights out approach, if you will, with the introduction of that tool when it's released here officially later this year. So very excited about that. We move then to the mounter, where we're undergoing the same types of exercises, right? Working again, as I said, with the usual suspects for development of connectivity, feedback, real-time, self-healing data to be able to, again, achieve this smart factory realization that we're all after. Hands off, lights out. It's not going to happen overnight. We know that, right? But you got to have a goal, and we're working in that direction and making significant progress. So you'll see from us something along that line here very soon as well with the mounter players out in the market that we're working with.
That's a very significant development, actually, because when we talked historically with lots of the inspection companies, and we talk about being able to adjust the machine. People say, well, they don't want to take ownership of the process. They don't want to tell somebody else's machine what to do. But presumably, you've now bridged that gap. You're working with DEC and other major manufacturers where you trust each other. But
That's right.
Are you taking ownership of the process then in making these decisions?
Yeah, we are actually, right? So, but it is a joint effort, right? So there's an element from us that we are providing to the customer. There's also an element from either the printer manufacturer or the mounter manufacturer that goes along with that. So to some degree, there's joint ownership, but at the end of the day, it's our data that's telling the system what to do in both cases. So ultimately, yes, we basically are at that point taking that ownership responsibility.
Great. Okay. So the last piece of equipment I think we're going to see today is the Alpha HS, which is the latest AOI system. So can we walk over and take? Yeah.
We certainly can. We certainly can. So the Alpha tool is our latest entry into the AOI marketplace. Now, this was introduced just over a year ago, about a year and a half. We've had very good success with it up to this point. The caveat is that we have packaged a what I will call in some people's opinion, maybe a more affordable AOI solution that still contains a significant amount of the very proven measurement-based Co-Young technology that we've utilized in our 8 projection Zenith system since the inception, right? So that's been very well received. The beauty in that is we now have a system that can be very well utilized for both pre-reflow and with the addition of a DLP, a 5th projector, post-reflow. And we're seeing that today. We're seeing very wide acceptance on the post-reflow front. Pre-reflow is something that we think we have a significant opportunity with because of the fact that it's still very new for a lot of people. But when we start talking about the Smart Factory Initiative and this feedback from an inspection tool to the mounter, it's coming from that pre-reflow environment, right? We want to pass along very integrity-filled data that's not been affected at all by the reflow process in terms of XY position, presence, absence, all of that. So we see that as a potential driver for pre-reflow going forward in the marketplace for all inspection system vendors. Again, we feel like we're kind of at the forefront with being ready for that because of this initiative to create these mount feedback tools with our partners, and again, be at the forefront of that evolution, revolution, whatever you want to call it. The other piece that we kind of folded into that release of the alpha system was our automated programming tool, KAP, as we call it. The next generation of that tool is also ready for release. And what that is allowing us to do is to not only utilize our existing AI engine library to very quickly come up with a match for packages and components during the programming cycle, but now also to then go into the customer's existing library and do the same thing, right? So the whole point of KAP, if you will, is to build the customer's library quickly. In any inspection realm, the main driver is to build the library as quickly as you can. Once the library is created, programming's a breeze, right? Everything is in there. You're just simply populating it for the next board you're programming. So what the KAP tool does is it allows us to very quickly, between, again, our AI engine, our package library, and the use of the customer's existing package library, continue to enhance, refine, and add to that library, which then accelerates significantly the programming process and reduces the time to accomplish that exponentially. To give you an example, Trevor, brand new customer, no library at all, using our KAP tool, we're seeing match rates of 70 to 80% right out of the gate with the components that they're using. You know, that means what used to take hours to create package types and basically inspection condition files for is now done virtually in seconds, right? Minutes, let's say. But you can kind of get the idea of where that's going and how that's going to continue to evolve. And that's another area, you know, kind of getting back to what Mike asked about, where utilizing the AI to the greatest degree possible, and we have, in our opinion, the best data set, you know, parametric, objective, profilometric, measurement based, to do that with, to get the kind of results that we're seeing. So lots of emphasis to be put on that as we go forward as well, and it'll continue to evolve and be refined and provide better and better results.
Yeah, I mean, automatic programming is definitely one of the things that have come into inspection systems over the last year and a half that have really made a big difference. But the fact that you're able to also now integrate your customers' library as well certainly helps us speed that process up as well. And I also agree with you on the situation regarding the pre-reflow inspection system. I think it's critical to get a holistic inspection process on the line to be able to control the process properly. But historically, it's always been a hard sell to try and get people to buy that pre-reflow system. So I'm guessing that you're probably having to make something that's you know, affordable and attractive in that respect to get people to buy into it.
Yeah, that certainly helps. And again, I think that's what we have with the Alpha series, Trevor. You're absolutely right. It's funny. We have some customers that have been pre-reflow from day one, and some very large customers, for that matter, to be quite honest. And the concept has always been that if they're controlling their print process using the SPI tools, and they're controlling their mounter process using pre-reflow AOI, they feel like they can certainly well enough control the reflow process to the point where nothing should change while that's going on when the board comes out of the oven, and it should be just exactly what it was predicted to be going in. those people are also now starting to migrate to adding that post as well. And as you had alluded to, the people that were fixated on post reflow from the beginning because they just feel like it gives them more coverage in its entirety, are looking at the landscape and understanding that there is improvement that can be made, can be seen by catching any of those particular anomalies or defects prior to the reflow oven. And then now they're just verifying kind of what they knew or were expecting with the post reflow tool. And then you add together the element of the smart factory realization and all the connectivity and what can be done with tools in the various locations. And it's all starting to build, you know, some momentum in that direction.
Okay. Well, sometime when we have more time, Joel, I'd love to talk about the types of results you get off of the post reflow system. But you know, for now, I think I want to say a very big thank you for showing us around your showroom. As Mike rightly says,
You're very welcome.
It's a fantastic experience, and congratulations to your cameraman who's obviously using a gimbal or Steadicam to shoot this.
He's got it figured out. That's right.
He's got it figured out. Absolutely. So thanks, Joel, and enjoy the rest of the show.
Trevor, thank you very much. I really appreciate the opportunity to show you what we have here. Look forward to doing it again. Look forward to getting back together face to face at some point. As much fun as this has been, and as nice as it's been to show you what we have here. Again, to your viewers, come see us. We're open. We'd love to spend more time with you. We could do a deep dive on any and everything that I discussed today and then some. But again, thank you for the time, and I hope the rest of the show goes very well for you.
Thank you. Thank you very much.
Thanks, Joel.
Okay.
Global SMT and Packaging opens the windows of the world to bring you the latest news and technologies from Munich, from Bangalore, from Shanghai, from San Diego.
So there you have it, Mike. I guess a little bit out of your normal area of expertise, I guess, the inspection business, but another area that is increasing and improving in leaps and bounds at the moment.
Oh, sorry, I had myself muted at the break. Yeah, I've talked to, in the podcast, I've talked to a few inspection companies, and it's fascinating technology, and particularly, you know, the early inspection systems, as I remember, again, not an expert in AOI, were, you know, really high resolution camera views. Now with all the computer algorithms and artificial intelligence and all that technology they're putting in, it's amazing the image that the computer can put together based on you know, the pixels it received, and be able to be 3D and rotatable and look around and under things with the side views is quite impressive, amazing.
Yeah, the quality of the camera technology is amazing. I think really the only real bottleneck is the computer power to crunch all that data, because you know it's massive. It really is. You know.
Yeah,
so
I think it still does take a while to render a high res image. It still takes time.
Yeah, that's true. That's true. So going back to what we were talking about earlier on your reliability podcast series, what are some of the big highlights and takeaways you've had from doing that in the last year?
I hesitate to use the word "my favorite interview" because I'll make one person happy and 62 people not happy. But one of the most memorable interviews was one that we did in January of this year, and that was with Dr. Eric Fossum, who was the inventor of the CMOS image sensor. And it's not often you get to talk to someone who invented something that, you know, I'm holding in my hand. It's quite impressive. And what impressed me about him, not only the deep technical knowledge that he has, and he shared the technical journey and the challenges of creating this CMOS image sensor, but the kind of down to earth. I asked him a question. I wasn't sure how he was going to take it. When you deal with PhDs and things, you just don't know what their sense of humor is. Sometimes it's wide and sometimes it's very narrow. And I asked him, I said, hey, Eric, do you just wake up some random mornings and just go, man, I invented that. Am I cool? And he goes, well, yeah. He goes, sometimes I do. I have to pinch myself. And my favorite story that he told was he and his wife were on vacation in Europe, and he ended up photobombing a group of people. And then he handed him his business card and said, just look me up. And he got an email a couple of weeks later saying, oh my God, OMG, you're the inventor of the camera phone, And so it's cool to see someone who has had a hugely disruptive effect on our industry for the greater good, mostly, be actually a real human being and can appreciate both. He can appreciate what he's done with a proper amount of humility. It's pretty impressive.
Sounds really cool. And one of the interesting things I've noted over the years is that a lot of these inventions happen by accident, and one of the most one of the ones that stands out to me is solder. I remember being in Japan once and meeting the inventor of the Kessler 907 solder, which was famous and used for years. And it was this fairly young engineer, and I asked him about what was the genesis of his research. How did he approach it? Was it customer driven? The usual stuff. He said no. I was playing in a lab one day. It was a complete accident. And I've spoken to a couple of other people who've invented sort of like SM100C from Nihon, and Tetsuro Nishimuro said again it was something that he was working in the lab one day and almost did it by accident, which I thought was really interesting. So what was the genesis?
The Post-it note was the golden child of the accidental thing. The Post-it note was supposed to be a strong adhesive, turned out to be a really sucky adhesive, and they found a use for it. The same kind of thing. In our industry, we've you're judged in life by how many successes and failures you've had. Unfortunately, not everyone sees the failures. They see the products that are successful. They don't see the ones that never made it out the door, right? Because we tend to do that behind the curtain. But even on failure products, we come up with this great idea. We think it's a great idea. We do all this engineering. We spend time. We build a machine, and it just doesn't perform. We always have takeaways from that. We always take away, well, the whole process doesn't work, but wow, we found this really cool pump or this really good whatever, and that ends up going into other products that make those products better. So there really is no failure in our world. It's a learning experience. Sometimes you learn more, sometimes you learn less, but you learn.
That's been one of the big takeaways of the shark pool project that we did this year, and because we sent these videos to these EMS companies, but they all filled out survey forms that told us what they thought about the product and what they liked about the product, but what they didn't like about it as well. And that was very useful feedback.
A focus group, basically, of potential buyers.
Correct. I can think of one customer that actually changed its business model as a result of it. But I mean, it's very useful feedback. It's you don't always hear the truth when you're talking to people face to face, but when you get them to evaluate things and give you feedback in a different format, then it really works. So anyway, I think talking about experiments, I think we're pretty much coming up to the end of today's broadcasting. I think I want to thank you very much for being brave enough to join us and to take this risk and journey with us.
Well, I do a lot of, as you know, I do a lot of online things, but I'm never brave enough to do it live. So I usually record it, edit it, make it look perfect. So thanks for allowing me to do it live. It came off really well. Thanks to Summer, who's working behind the curtains, that's making all this happen. And thank you for inviting me.
Yeah. Wonderful. Well, it's been a pleasure, Mike. And I know, as I've said to so many people today, I certainly look forward to catching up in person at Casa Conrad in Rancho Cucamonga.
Well, Yeah, Chino Hills, California, just south of LA, and then we can cheer each other properly when
Yeah.
that day comes back. It would be good to see you again in person, Trevor.
Absolutely. You know, give my best to Debbie, and great to see you. And thank you for taking part, and thank you for our audience for watching. We hope you've enjoyed it, and look forward to catching up tomorrow, where my guest, my co-host, should I say, will be Michael Ford from Aegis, who's heavily involved in a lot of the IPC work on the 1972 security standard. And there's a lot more to that than meets the eye, believe me. So tune in for that tomorrow. Until then,
Yeah, he was a guest